Welcome, young detectives, to Mathville Mansion. I'm Justin, and today we've been invited by the brilliant Professor Puzzleworth to tackle a series of mathematical mysteries. The professor is known for his love of puzzles, and he's hidden them all throughout his massive mansion for us to solve. Now, I'll admit, puzzles can be tricky, and some of these might really test our skills, but I know that by working together and giving it our best effort, we'll find success. By the end of today's lesson, you'll be able to solve addition and subtraction problems up to the millions and regroup as needed. Have your guided notes ready, and let's unlock the secrets of Mathville Mansion. I kind of thought the professor would be here to let us into the mansion, but check it out. Our first puzzle. A 3-digit number, a 4-digit keypad, and a riddle. To open the door, regroup, and you're done. Change what you need to get some more ones. Well, 702 already has 2 ones, so how can we regroup to get more? Remember, regrouping is changing the way an amount is grouped while keeping the total value the same. To get more ones, we could regroup a 10 into 10 ones, but 702 has a 0 in the tens place. What can we do instead? Let's start by regrouping 100 into 10 tens. And then how could we regroup to get more ones? Right, regrouping 110 can give us 10 more ones. We had 700s and 2 ones. Now we have 600s, 9 tens, and 12 ones. Does that change the total value of our number? Nope, it's still 702. We just regrouped. 6, 9, 1, 2. We're in! Wow, this place is huge! I wonder where the professor wants us to go first. Ooh, another puzzle. It's an addition problem. 9,756 plus 872. There are lots of strategies for adding numbers, but let's practice using the addition algorithm, the step-by-step process for adding multi-digit numbers. We'll line up our addends, or the amounts being added together, in place value order. Ones with ones, tens with tens, and so on. Then, where do we start adding? The ones place. 6 plus 2 equals 8, so we'll record an 8 in the ones place. Then, moving to the tens, we have 5 plus 7. That equals 12 tens. Can we record 12 in the tens place? Nope, only 1 digit can go in the tens place. So we need to regroup it as 100 and 2 tens. That 100 will get added to the other hundreds, and then we'll record the 2 tens here as part of our sum, or answer. Pause here to finish solving the rest of the addition problem in your guided notes. Adding the digits in the hundreds place equals 16 hundreds, which can be regrouped as 1,000 and 6 hundreds. Then 9 plus 1 equals 10 thousands, which we can regroup, but do we need to? Since we don't have anything else to add, we can just record those 10 thousands as part of our sum. Hey, did you notice the numbers on those columns earlier? The number on the left, 10,628, matches our sum, and it's pointing to the library. Let's head over there. Before we start the next puzzle, let's check the room. Ooh, there's our clue. What do you notice about the books beneath it? There's a 7-digit number on each book spine. Let's keep that in mind as we solve. Ooh, wow. 4,627,529 plus 2,945,356. Those are some pretty big numbers. Do you think we could use the addition algorithm again? We know it works with 4-digit numbers, so let's try it with these 7-digit numbers. We'll line them up in place value order and start by adding the digit in the ones place. Pause here to try solving it on your own first, and then we'll check it out together. When using the addition algorithm, it doesn't matter how big the numbers are. We can just keep adding, regrouping as needed, and moving to the next place until we're done. Take a moment to check your work with mine. Did you get the same answer? If not, that's okay. Mistakes are a natural part of the learning process, and regrouping errors and minor addition mistakes can happen to anyone, even me. If your answer is different, pause here to compare and correct your work if needed. So, is our sum on one of these books? Woo, here it is. 7,572,885. Whoa. A secret compartment with a key to the study. Let's go find the puzzle that awaits us there. Ooh, our next clue might have something to do with the numbers on that desk. Looks like we'll need to subtract to figure out which drawer to check. To solve 6,042 minus 3,417 using the subtraction algorithm, we'll line our numbers up by their place values and begin subtracting in the ones place. We have 2 ones and need to subtract 7. Remember, we're subtracting from our minuend, or starting amount. Do we have enough to subtract 7? Nope. So where can we get more? Just like the puzzle at the start, we will regroup a 10 to get more ones. Now we have 3 10s and 10 more ones, adding up to 12 ones. 12 minus 7 equals 5, so we'll record a 5 in the ones place for our difference, or answer. Pause here to finish solving the subtraction problem in your guided notes. Moving to the tens place, we have 3 minus 1, which equals 2. There's a 0 in the hundreds place, and we need to subtract 4. Do we need to regroup? Yeah, so let's regroup 1,000 as 10 hundreds. Now we can solve 10 minus 4, which equals 6, and 5 minus 3 equals 2. That means the difference is 2,625, matching the number on the bottom drawer. Ooh, looks like we need a 7-digit code to open the drawer. Solving 8,740,516 minus 316,809 should give us the code we need. Fortunately, with the subtraction algorithm, we can just keep regrouping as needed, subtracting and moving to the next place until we're done. Pause here to try solving this problem on your own first, and then we'll check it out together. First, we need to line up our numbers in place value order with the minuend above the amount being subtracted. Then, starting in the ones place, we have 6, and we need to subtract 9. We can regroup 1, 10, which will give us 10 more ones, for a total of 16. 16 minus 9 equals 7. Then we have a 0 in the tens place, and we need to subtract 0. Do we need to regroup? Nope. 0 minus 0 just equals 0, which we'll record in the tens place. But then we have 5, and we need to subtract 8. Where can we get more hundreds? There's a 0 in the thousands place, so we'll need to go all the way to the 10,000s place. We'll regroup one of them as 10 thousands. But then, how do we get more hundreds? We need to regroup one of the thousands as 10 more hundreds. Now we have 15 minus 8, which equals 7. 9 minus 6, which equals 3. 3 minus 1, which equals 2. And 7 minus 3, which equals 4. And don't forget, this last digit here in the millions place, 8 minus nothing, is 8, for a difference of 8,423,707. Whew! A big red button? I wonder what it does. Actually, I'm gonna wait to push the button until our next lesson, since we are out of time today. Sure is tempting, though. So, what have we learned today, besides the fact that Mathville Mansion is full of all sorts of cool secrets? Well, now you know that the addition and subtraction algorithms are step-by-step processes we can use to add or subtract numbers of any size. You also know that regrouping is necessary when the sum of a single place value is more than one digit, or when the amount being subtracted is more than what is available. Be sure to complete the practice questions and extension activities that go with this lesson to practice adding and subtracting numbers up to the millions. We'll figure out what this big red button does in our next lesson. Until then, remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.